So you may have noticed that there was this pattern when we were dealing with the limit definition of these derivatives back in the last section. We took limits of functions like this one. This is an easy one, right? We would say that this derivative would be the limit as h approached 0 of, well, let's see, x plus h minus x is just h over h. And we know that that limit comes out to be the limit as h approaches 0 of 1, and that's 1, right? Because the limit of a constant is always a constant. In this case, that constant is 1. So, all right, if f of x is equal to x, f prime of x is equal to 1. All right, well, let's see, is there another pattern right here? Well, let's take the limit as h approaches 0 of x plus h squared minus x squared over h, the derivative of x squared. And we practiced a few like this one. When we expanded our expression, we would be taking the limit as h approached 0 of x squared plus 2 times x times h plus h squared minus x squared divided by h. And so simplifying this limit in order to be able to evaluate it, we're going to take that limit as h approaches 0 of the x squared term just subtracts out, leaving us with 2 times x times h plus h squared divided by h. Since h is a common factor to both the terms in the numerator, we can divide it out, and we're left with the limit as h approaches 0 of 2x plus h, and as h goes to 0, we're left with 2x. So if f of x is equal to x squared, f prime of x, well, that's 2x. Now, interesting things right here so far, right? We can see that there's something with it. I'm not sure I see a pattern yet. So let's try it again. This time, let's use x cubed. And I'll do the expansion for you. I'll just show you how this goes. This means we would be taking the limit as h approaches 0 of this quantity. It would be x cubed plus 3x squared times h plus 3x times h plus h cubed this time. And we're subtracting from that x cubed divided by h. And if you notice what happens right here, already there's probably a pattern forming in your mind, but let's take a look anyways. Those x cubed cancels out, right? That looks like what's happening each time, right? The x is canceled out here, x squared canceled here, so x cubed must cancel out here. And we're taking this limit this time as h approaches 0 of the quantity 3x squared h plus 3xh squared plus h cubed. And all of that is over h, and since h is a common factor to each of these terms, we can factor out that common h and take the limit as h approaches 0 of 3 times x squared plus 3x times h plus h squared. And of course, as h goes to 0, these last two terms drop out, and we're left with 3x squared. And so if we take our derivative of x cubed, we might notice we get f of x is equal to 3x squared. Do you see the pattern yet? Sometimes people do, sometimes people don't. There is one going on right here, but you know what? Let's take one more try at this, one more whack at this to see what's going to happen. So let's use x to the fourth, and again, I'll show you how the expansion of this one works. When we take x, that should be x plus h to the fourth, we're taking the limit as h approaches 0 of. In this case, we end up with x to the fourth plus 4x to the third h plus, this becomes 6x squared h squared plus 4x times h to the third plus, let's see, we get h to the fourth minus x to the fourth at the very tail end of that, and that's all divided by h, of course. As we saw before, the x to the fourth terms drop out by subtraction, so we're going to be taking the limit as h approaches 0 of, let's see, 4x cubed times h plus 6x squared times h squared plus 4x times h cubed plus h to the fourth power. Again, we're dividing by h, which is a common factor to each of those terms. And so when we cancel out that common factor of h, we're left taking a limit like this one. The limit as h approaches 0 of 4x cubed plus 6x squared h plus 4x times h squared plus h to the third, but it doesn't really matter what happens with these last terms, because as h goes to 0, we're left with 4x cubed. You see the pattern now? That's right. What we have just established is that, well, it looks like if I have a whole number power here, then what I should really do is take that power from the exponent position, put it in front, and then just subtract 1 from that exponent. And that is indeed the pattern right here. If we went on and we found our derivative for f of x equals x to the fifth, what do you think we would find? Well, that's right. We would find that f prime of x should be 5 times x to the fourth. And there's your pattern.